Some designs must have robust isolation. Yes, I'm looking at you, EV charging station. Actually, isolation is vital for many other applications, including solar panels and energy storage devices. So, if you're designing one of these kinds of applications, most likely you're going to need an isolated gate driver supply. But where can you find an isolated gate driver supply that provides efficient power transfer, ensures electrical isolation between low voltage control and high voltage power stages, and can provide isolated voltage to gate driver circuits of high power MOSFETs, IGBTs, and silicon carbide and GAN transistors? Oh, yeah, and improves safety, prevents ground loops, and reduces noise coupling in switching applications. Right here, my friends. Right here. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Ritesh Ritesh from Infineon and I explore the what, where, and how of Infineon's 2EP1xxR IceDRIVER Power family. We investigate the working principle of these drivers, the topologies supported by these solutions, and how these drivers can enable simple, space efficient, and highly configurable isolated gate driver supply for a variety of switches. And before we get started, don't forget to click that link. There you can find even more information about this topic from Infineon. Hi, Ritesh. Thank you so much for joining me.
Hi, Amelia. Thank you so much for having me here.
So, we're talking about the 2EP1xxR full bridge transformer driver today. But before we get started, what all will we be covering today?
So today I'll be talking about Infineon's newly launched 2EP transformer driver. It's a key addition to our portfolio that makes Infineon as a one-stop shop for almost all the gate driver solutions. Today I'll begin by introducing the parts itself. Then I'll walk you through its working principle. After that, I'll cover its key features, followed by a look at the target applications and the unique value propositions that 2EP brings to the table. And then finally, I'll wrap up by sharing the support materials available for the designers who wants to explore the solution further.
Fantastic. Now, Ritesh, what exactly is an isolated gate driver supply?
So there are different applications such as EV charging, drives, solar energy storage, etc., where isolation is critical for safety, performance, and reliability. Let's take an example to understand this in detail. In EV charging, there are different power stages such as AC to DC conversion stage, DC to DC conversion stage, and inverter stage, and in which you requires IGBT or SiC GAN MOSFETs. For these switches, you require isolated gate drivers to protect the low voltage control systems from high voltage power stages. And these drivers prevent electric shock or block noise propagation into logic circuits. Now, these isolated gate driver requires power supply on their output side, and this power supply must be isolated as well. Because if you break these isolations, you defeat the safety and EMI benefits that you have from these isolated gate drivers. And that's why you require isolated gate driver supply. It's a power supply that provides isolated supply voltages to the gate drivers by using a high frequency transformer for galvanic isolation while transporting power. There are different topologies such as full bridge, half bridge, flyback converters, push-pull converters. And the isolated supply ensures efficient power transfer and provides dual output for improved control and ensure safety in switching applications. So with 2EP, we are actually extending the popular Infineon phrase that every switch needs a driver and every driver needs a power supply.
All right. So, Ritesh, since every switch needs a driver and every driver needs a power supply, let's talk about that power.
2EP is a full bridge transformer driver that has been designed with the aim of reducing system cost and enhancing the reliability of the system through its integrated protection features. It's an IC in a very compact package to generate an asymmetric output voltage with its unique duty cycle adjustment ability to supply isolated gate drivers. It can cater to different switching technologies such as SiC, GAN, IGBT, and it can be used in any applications that require isolated supplies.
Ritesh, this family includes a couple different variants, right?
Yes, we have four variants in this family to cater up for a variety of applications. We have 2EP100R, we have 2EP101R, we have 2EP110R, and we have 2EP130R. All four variants of 2EP family are pin compatible that allows designs for one to be easily utilized for another depending upon the requirement by removing registers or placing 0 jumpers. The ideal 2EP transformer driver types can be selected based on their specific requirements, including adjustment of positive to negative isolated output voltage ratio via duty cycle pin, limitation of maximum output voltage current via overcurrent setting, switching frequencies. So typically 2EP100R can be used for IGBTs, 2EP101R is for SiC MOSFET gate driver supplies, and the last two variants, 2EP110R and 2EP130R, offer flexibility in uses. I'll be sharing more about the differences among them in coming slides.
Fantastic. Now, Ritesh, talk to me about how this solution works. Let's review the working principle here.
Sure. Let's start with the general operating principle. There are different topologies supported by 2EP, such as peak rectifications, full wave rectifications, and the voltage envelope rectification topology. For understanding the operating principle, we'll look at the peak rectification topology. This one is the suggested solution because of its flexibility and wide range. The isolated supply with 2EP is simple to build and consists of built-in blocks such as input decoupling to handle the input ripple current, the 2EP for PWM generation, protection, and power stage that converts the applied direct curve voltage to a power PWM pattern, a series capacitor to block the DC voltage component from the transformer, which is basically an offset generator, the transformer which provides the isolation from primary side to secondary side, and the adaptation of the input voltage level to the required output voltage level, a rectification stage, which in this case is a peak current rectification, and finally the smoothing output capacitors for the bipolar output stage, where the ratio between the positive and negative voltage is adjustable via the duty cycle of the PWM of 2EP. Let's visualize the voltage waveform leaving the individual blocks of this circuitry. First, the input decoupling capacitor is supplied with the DC voltage. Within the 2EP, the DC voltage is converted by the full bridge output stage into a rectangular output voltage with a configured frequency and duty cycle. If the duty cycle is 50%, the output voltage at each output has a voltage swing between ground and VDD, making the output voltage between out1 and out2 two times the supply voltage or plus minus VDD reference to out2. The rectangular voltage is applied in the upper leg to the series capacitor. For the symmetric waveform with 50% duty cycle, the capacitor operates like a short circuit. However, in case of asymmetric waveform, these capacitors will add the offset voltage to the waveform proportionally. These voltages are applied to the transformer primary side, which gets divided by the transformer transfer ratio to the secondary side voltage. Now we have an isolated voltage on the secondary side. Using peak rectifications, we rectify the positive side voltage to the level of VCC and negative voltage to the level of VE. After smoothing of the pulsed secondary voltage by the output capacitor, we get two DC voltages with the same ground to reference. So in general, most applications uses asymmetric isolated supply voltage and 2EP with adjustable duty cycle features when used in peak rectification methodology make it simpler to generate voltage as required. For instance, with a duty cycle of 33% and a transfer ratio of 1.25 to 1 can generate plus 15 VCC and minus 7.5 VV. Similarly, with different duty cycle and turn ratios, you can generate other asymmetric voltage ratios. Here are two equations for the output voltages VCC and VE, which you can use to calculate different parameters.
Ritesh, explain to me a bit about the different supported topologies here.
As I already shared, beside peak rectification topology, 2EP supports other common topologies for single and bipolar isolated output voltages with different pros and cons. First, voltage doubler peak rectifications. It is often used for isolated voltage, output voltage with a fixed 2:1 ratio of positive to negative output voltage. It's a good ratio for IGBT supply, but limits the uses of modern switches, such as silicon carbide MOSFETs. A voltage double with a single winding output will introduce an asymmetric current load on the transformer. and such conditions can drive the transformer into saturation. So it requires series capacitor at the input. The second one, the full wave rectification topology. It's a most known topology for single output voltage. Since 2EP family supports this rectification topology with the selected duty cycle of 50%, the main advantage of this is low output voltage rival. However, the disadvantage is high number of diodes and single output voltage for the gate drivers. And last, peak rectification topology, which is the most suggested solution in this case. With different duty cycle, we can generate asymmetric voltage easily as per the requirement. It has wider range of output voltage ratio ranging from 1:1 to 9:1, which makes it versatile and easy to use for any type of solutions. The solutions provide a good opportunity for further BOM reduction.
All right. So, Ritesh, let's also talk about the features of this solution.
Let's start by looking at 2EP100R and 2EP101R and the sum of the features that are common to all variants. In the 2EP family, the supply is monitored by UVLO block, ensuring a defined startup upon passing the UVLO threshold of typically 4.3 volt. All the variants uses an accurate trimmed oscillator to generate PWM frequency. For 2EP100R and 101R, there are two available frequencies, and one out of these two frequencies can be selected by pin strapping. Then we have an accurate duty cycle set block, which generates duty cycles for the two variants. One out of two available duty cycle per device can be selected by pin strapping to adapt the duty cycle to the required positive to negative output voltage ratio. 2EP has powerful and robust full bridge output stage, which is designed to directly drive a transformer to generate isolated output voltage from the supply voltage. Finally, all members of 2EP supports several protection mechanisms at the full bridge stage to ensure reliable operation, including average overcurrent, peak overcurrent, and over temperature protection.
So, speaking of overcurrent protection, how does this solution deal with overcurrent?
Average overcurrent detection monitors out 1 and output 2 output current over two consecutive on and off times. If the output current is above the dedicated average overcurrent for more than 50% of the time, the 2EP will detect an average overcurrent and turns off the output stage. It will also send false signals to the ready pin and performs a restart. Typically, this feature is used as a system overcurrent protection. If the system becomes overload, that is, if the output current is higher than the design current according to the average overcurrent threshold, the 2EP turns off temporarily. Since we have already discussed average overcurrent detection, let's dig into peak overcurrent protection. This blocks helps to monitor the peak output current of out 1 and out 2, and if the output peak current is above threshold for more than the filter time, the 2EP detects and turns off the output stage. It then sends the false signal and perform restart. Typically, peak overcurrent detection is used as short circuit protection, but it acts as transformer saturation detection.
So, over temperature protection is also a crucial aspect here as well. So, Ritesh, how does this solution address this issue?
While designing 2EP, we realized that it's a critical protection as well in systems. So what over temperature block does is that it monitors the IC junction temperature. If the IC junction temperature is above the over temperature threshold, the 2EP detects an over temperature fault, signalizes the fault via ready pin and performs a restart. And this way 2EP helps to maintain the IC junction temperature at optimal level. Now let's look at other blocks as well. First, pre-charge function, which charges the serial capacitor before the PWM is applied to the full bridge output stage. It is applied for duty cycle between 10% and 44% and ensures a proper startup during soft start. Second, soft start block, which is designed to ensure a startup of the open loop system into a larger output capacitance or increased startup current. 2EP is equipped with two features to enhance the soft start. Peak current mode is startup with increased peak current, high frequency startup with 360 kHz. And these features ensures a good start of isolated output voltage. Last, 2EP is equipped with a ready open drain output to indicate that device is properly supplied and configured.
Can we also look at the EP11OR member of this family as well?
Yes, So 2EP110R differs from previously shown versions by a fine, granular, adjustable, and accurate data cycle set block. It provides a duty cycle adjustment range of 10 to 50% with one step size, offering a wide range for adjusting the positive to negative output voltage ratio.
What about the 2EP130R solution? Can we also take a closer look at this one?
In addition to adjustable duty cycle features of 2EP110R version, 2EP130R offers a 5-level average overcurrent protections to adapt the 2EP130R to several systems overcurrent protection requirements. It provides fine granular adjustable switching frequencies from 50 kHz to 695 kHz, adaptable to wide range of external transformers. And in addition to that, it provides the functionality of bypass mode, that is, transformer driver follows an applied PWM signal in frequency and duty cycle. And all these features make this particular variant a most flexible and versatile one.
So, Ritesh, how do the different solutions in this family compare?
This slide shows a quick snapshot of how these variants differ from each other. 2EP100R and 2EP101R have two options for duty cycle, whereas 2EP110R and 2EP130R have adjustable duty cycle. Similarly, there are only two switching frequency options for 2EP100R, 101R, and 110R, whereas 2EP130R have adjustable switching frequencies. 2EP130R also comes with adjustable overcurrent threshold and bypass mode, which others don't have. Lastly, the protection features are all available in all the options.
So, Ritesh, talk to me about the applications this solution would be a good fit for.
The application scope for 2EP is extensive. In addition to serving as gate driver supply for IGBT, GAN, and SiC MOSFET switches, it can be utilized in any application that necessitates an isolated low power supply from 5 volt to 20 volt input source.
So I would imagine that solar inverters would be a good application.
Yes, a gate driver supply is implemented in all kinds of power applications, such as solar inverters, motor drive inverters, and EV charging applications, to name a few. Or as I earlier said, wherever you use isolated gate driver, you would require isolated power supply. And you do often find them adjacent to power switches and gate drivers on the PCB.
Ritesh, what are the biggest benefits of EiceDRIVER Power?
The isolated supplies must be user-friendly and cost-effective in terms of bills of materials. This is where 2EP comes, a full-bridge transformer driver. Let me show you this with a quick example. If you compare 2EP with discrete solutions, you can easily find that it significantly brings down bill of material cost and reduces circuit complexity and area. Since it has inbuilt push-pull stage and other control circuitry, you really don't require any other circuitry other than 2EP and few resistors. Also, due to its ability to generate asymmetric output voltage, it's ready for SiC MOSFETs. And since it's highly flexible, it's easy to plug and play isolated power supply solutions, which makes it user-friendly and cost-effective.
So, Ritesh, we could use this solution for silicon carbide, IGBTs, and GAN as well, right?
Yes, 2EP EiceDRIVER family is designed to meet the needs of IGBT, GAN, and SiC MOSFETs gate driver supply, as well as other applications. With its different variants, it can cater to all type of applications.
Excellent. Now, what kind of evaluation boards does Infineon offer for the EiceDRIVER Power family?
We have three types of evaluation boards. The first one is Eval 2EP130R PR. In this board, there is no transformer pre-assembled on it. Instead, there are three different transformers co-packaged with the board, and the customer can decide to solder and assemble any of these three transformers based on the applications. The details of the transformer are there in the transformer transfer ratio of 1.25:1, 1.5:1, and 1.4:1. The next evaluation board that we have is Eval 2EP130R PRSIC. It comes with the transformer pre-assembled on the board, and with the input voltage of VDD 15 volt, it generates plus 18 and minus 2.5 volt for the high side and low side gate drivers and suitable for SiC MOSFETs. And the last one is Eval 2EP130R VT, which is different from other boards, but it uses a voltage doubler configurations on the rectification circuit and generates 15 volt and minus to 7.5 volt for the high side and the low side gate driver respectively. This is mostly suitable for IGBT applications. And using these ports, designer can easily and comprehensively evaluate our 2EP devices.
Fantastic. Now, Ritesh, if my audience wants more information about this solution, what kind of supporting assets does Infineon offer?
So there are many materials which are available on our product web pages, such as datasheet, product presentations, footprints, and models. Designer can easily find all the details information in them. Apart from this, they can order our boards, watch video trainings to get more detailed insight on this. And here's a link of our product web page, which US can visit and find out about our products in detail. Also, last but not least, they can also check out Infineon Gate Driver portfolio. I'm sure that they would find 2EP interesting, so they should check out our drivers too.
Fantastic. Well, Ritesh, I think that's all I have time for today. Thank you so much for joining me.
Thank you, Amelia.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Infineon. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EEJournal.